So why is math taught differently now? It's a question that so many parents are asking and want the answer to. And it comes up because you might be seeing things on your students' homework, that techniques that look really inefficient or overly complicated. Maybe your child's being asked to explain in their own words how they figure out what 9 plus 4 is, and you're thinking to yourself, well, 9 plus 4 is 13, that's just something they should memorize. And so there's a lot of confusion about what's going on. And I think it's important to look at how have we taught math historically and why are we making this change? So historically, we've mostly been showing kids when you have a certain situation, these are the steps you need to follow to solve that kind of problem. And oftentimes avoiding or not covering or teaching them how to understand what they're doing and why they're doing it. And so what we're trying to do now is strike a balance between memorized procedures and algorithms and actually understanding what you're doing so that kids can think and become better problem solvers. So let me give you an arithmetic example of that. Suppose you had to do 312 minus 297. If you only learned a standard algorithm, then you would be forced to do the following. You would have to write the problem up like this, one number underneath the other, and you would start over here on the right, and you'd say, well, I've got to do 2 minus 7, but I can't take 7 from 2, so I have to regroup or borrow. So I turn this 1 into a 0, and then that into a 12, and then I subtract. 12 minus 7 is 5. And then I move over to the middle column, and I have this problem again where I can't take 9 from 0, so I borrow again, and I have 10 minus 9 is 1, 2 minus 2 is 0, and so I have that answer, 15. So it seems like it works. Hopefully we followed all the steps correctly. It was a lot of them, and not all of them, maybe some kids don't understand why they're doing what they're doing, but they know how to execute that procedure. And you get an answer, and hopefully that's the correct answer. But if I ask you to think about it and really try to understand what does this mean, this subtraction thing, what I've found is a lot of people will do this mentally, and they'll do it very naturally, and they'll do it like this. They'll say, well, 297 from 312, that's really a difference. And so if I think about this on a number line, here's 297, and over here a little ways down is 312. And I know that this is really close to 300, so 300 is over here in the middle. And to go from 297 to 300, that's just 3 units. And to go from 300 to 312, that's 12 units. So 3 plus 12 is 15. And so you get the answer, and it makes some sense. Now, when I draw it all out, it might feel like that's a lot of extra effort, but you can do this mentally once you understand what's going on. And a lot of adults have figured this out on their own, and we haven't really systematically taught this to students until recently. So now we're giving kids more than one way to think about things and choose the one that's most appropriate. Now keep in mind, this is still part of what we teach kids. It's not like we've removed the standard algorithm. It's just that we're teaching them other ways as well, and sometimes these make more sense than this mechanical algorithm. So what do we really want? We want kids to be fluent in mathematics. If you think about what fluency means for foreign language, it doesn't just mean memorize a few phrases so you can get around on your vacation to France or whatever. It means that you can actually have a conversation with somebody and you know the subtle differences between what this word means and what that word means and when it's appropriate to use which one. Same thing in mathematics. You need to know more than one way to do things and when it's appropriate to apply each of them. That's what we want kids to be in mathematics, is fluent like that, right? This is going to prepare them for the advanced concepts they're going to see later on when math gets more complicated. So the real goal here is to help kids understand, to strike a balance between understanding and memorization, and help them learn how to think for the long run. So here's another example of where this could apply. Let's look at multiplication. What about 43 times 36? Again, we have to line it up vertically because that's the one way that we learned it. When we do 3 times 6 is 18. We're only allowed to write the 8, the 1 we have to carry up here. Then we do 6 times 4 is 24, and then we add in that 1. So those are some memorized steps that not everyone really understands why they're doing it, they're just executing. In my day, we called this the placeholder 0 that we have to put down here at the bottom. And then we do 3 times 3 is 9, and 3 times 4 is 12. And we add this up, start from here. That's 14, carry the 1. You get 1,548. And again, hopefully that's right. But what's really going on here is we need to really think about place value when we do this. When we do this first step, we really are doing 6 times 3, which is 18. That's easy. But this next step, 6 times 4, that's not really a 4. That's a 40 because it's in the tens column. So what's 40 times 6? Well, 40 times 6 is not 24. It's 240. So I'm just going to go ahead and write that down right there. And you'll notice that the sum of these is the number that we had already up here. And then we'll move over. We'll do 30 times 3, which is 90. And 30 times 40, which is 1,200. And there you go. There you see it again. That's 1,290 there. That's right there. So we haven't done anything differently. We're just being more explicit in how we call out the place value. And then we can add it all up and we'll get the same thing. So this is another example where just going through these what may seem like inefficient extra steps is illustrating for our students what's going on with the actual place value instead of obscuring it here. Standard algorithms are designed to be really efficient, but sometimes they obscure what's going on in terms of the understanding. So hopefully with those two examples, you're seeing how we're trying to teach kids how to understand what's going on, as well as learn the algorithms that are going to help them do things efficiently, right? And with that understanding then, we're preparing them for the more advanced concepts they're going to see, and we're teaching them how to think and solve problems instead of just memorizing algorithms.